Suppose I have let's say some hollow cylinder. Okay, a hollow cylinder. And suppose that in this hollow cylinder I have a piston. Okay, this is a hollow cylinder. I have a piston, so that's something that looks like this. So that there's like a disc inside that can move, and then there is a piece of rod attached to it. Like that. Make it a bit longer. Okay, so and inside this, so this piston can move in and out, and inside this is just air, right? Let's say it's just air inside, just normal air. Now let's say I put maybe I put a fire or something under it to heat up this cylinder, so that the air inside gets hot and it wants to expand. Okay, the air wants to expand. Let's get hot, the pressure increases and it wants to expand. Now I can, if I put a box down here, if I just want to see what happens, right, just for fun, I put a box down here. Then when the air when the air pressure increases, it expands and pushes out the piston. Piston pushes the box, and the box moves. Okay, so that's my setup here. Now I'm interested to find out how much work this air can do when it pushes at the box. How do we find the work done by the air? Let's start by thinking about going back to work done, to the meaning of, or to the way to calculate work done. You know that work is force times distance, F times D, force times distance. So if I have air, how can I find the force from the air? Well, if we have air, we want to talk about pressure. And from the pressure, if we know the pressure, we can, and the area that it pushes on, we can find the force, because we know that pressure is equal to force divided by area. So you see, I have a force here and I have a force there, so there is a connection. Okay. So what I'm interested in is to find out, if let's say the hot air here has a pressure P, and as it expands, let's say it moves the piston by a certain distance D, let's say 0.1 meter. I want to find out how much work it has done. Okay. Now there is another bit of information I need. I need to know the area, right? To find force from pressure, I need to know area. In this case, it would be the area of this part. Let's say the area of the piston. Let's say that area is say 0, maybe 0.1 as well, 0.1 meters squared. I'll make it smaller, 0.01 meters squared. Now air pressure is normally quite big. Air pressure is usually about 10 to the power 5 or so in SI units. Let me say that it is say 1.1 times 10 to the power 5 Pascal. Pascal is actually newtons per meter squared. Remember that? Okay, so let's say that's the air pressure, and it's a bit bigger than atmospheric pressure, which is just 10 to the power 5 or quite close to that. So it pushes the piston out and moves the object. So with all this information, what can I do if I want to find a force? Okay, let's go back to find the work. Let's go back to the formula for the work and see how we can work that out. So the work done is equal to force times distance. Now force, we know from here force is pressure. Force over area is pressure. Okay. Now the force applied here, the force applied here is related to the pressure P, we should call P, by A times P. So let me write this out. Work done is force times distance. Okay. Now force is actually pressure times area. So pressure times area. We need to use the pressure and area because we don't know the force directly. Usually for air we can measure the pressure, and for the piston we can work out measure the area. So pressure and area is what we normally measure. Now D is the distance moved, so we can measure that. Okay, A times D. Okay, so with this value we can actually find our answer because we know pressure, we know area, and we know the distance. So just put in the numbers and find an answer. So this is what it will look like if we actually work it out. P is 1.1 10 to the power 5. 1.1 times 10 to the power 5. A is 0.01 times 0.01, and D is 0.1, so times 0.1. So if you multiply all these together, so that's 10 to the minus 2, 10 to the minus 1. So therefore, this becomes, so the power of 5 become subtracted by 2 and 1. So that gives a power of 2. So we get 1.1 times 10 to the power 2, and work done is in joules. So that's how we can do it. Now, what I like to do is to go back. Let me just go back to this expression here. P times A times D. I like to express this, write this differently, a bit differently. I like to look at this AD. Okay, if you look at this A, which is the area here, which is this area here, and D, which is the distance we say it has moved. Now, imagine what happens when this piston moves from there over this distance to here. Right, it moves from original place to this place. When it moves from there to there, the volume of the air inside has increased, and it has increased by this amount. It has increased by the amount over this distance. And This volume, this increase in volume is just the area times the distance. It's just A times D. So A times D actually has a meaning. Alright, A times D actually mean the volume increase. Okay, so for this reason, it is we often write in physics. We often write the work done by a gas in this way. Instead of writing it P times A times D, we often write pressure times the volume increase, which is usually written in this way, this triangle thing, and V for volume. So this triangular thing, if you have not seen it before, is a Greek letter which is pronounced as delta. It's like the Greek language version of the English letter D. So that's delta. We read this by saying delta V, and we think of delta V to mean a volume change. Okay, we think of this delta V. So delta V, we think of it as change in volume. Alright, so whenever you see the delta symbol in front of a letter in physics or in mathematics, it often means change.